Okay, guys. So in last session, we have seen how we can connect to ADLS. I mean, blob or ADLS. How can we connect and how to do some operations, DB utils operation. Uh, Also, we have seen how can we parameterize the notebooks using input widgets. We have shown how to create some widgets. Okay, and also we discussed delta tables, right? Internal and I mean managed delta tables and external delta tables, how to create them. Okay, so why we use external delta tables? Even though we can store those delta tables in database memory. Why we use external delta tables? Why we save inside ADLS or S3 bucket? Because of security reason, and whenever you want to migrate those tables to other environment or other Databricks environment or other ADLS storage accounts, then it is very easy to migrate also. So it is not possible to migrate what managed delta tables. It is very easy to migrate what these external delta tables, and they are more secure. Okay, yes. And also we have seen how versioning will be useful. I mean, so how we have seen so the versioning also. Let's discuss. So we are creating some notebooks, and we are doing some transformations, and we are doing all this. But how can we what in inside ADF we have schedule? I mean, to schedule any pipeline, we are we are using triggers, right? So here in Databricks also we can create jobs. So in ADF, the same thing what triggers do, here jobs will do. Okay, jobs or pipelines you can see here. So here we can create some if you have some notebooks, if you want to schedule them, so then we can create them as jobs, and we can automate them. So no need to run manually, we can automate them. Okay, so how to create these jobs, job scheduling? First we will discuss. The first topic today is job scheduling. Okay, so it allows. So what is the purpose of this job scheduling means? So it allows to automated notebook execution. So the notebook execution will be automated. Okay, so if you want to run, so if you want to process the last day data, so 24 hours data you want to process, so at what time you want to execute your notebook? So you want to run the notebook at 12 a.m. exactly. So it will fetch the data from 12 a.m. to 12 a.m. means one day data, one full day data. So if you don't automate the notebook no execution is not automated. Then what we have to do? So we have to woke up at 12 a.m. and we need to run that notebook, right? So it is not what advised, or it is not the best practice. So what we can do? We can use this job scheduling. Okay. Okay. So why we use this job scheduling? To automatic our notebook execution, and to run notebooks or workflows on a schedule or based on a triggers. So if only one notebook there, we can manually run it. Okay. So for suppose daily 10 a.m. we have to run. Okay, we can manually run. But there are sequence of notebooks. I mean, you are creating. So Darshan is working on job data extraction, and Vikas is working on what data transformation, and Sidhu or someone, Niveta, someone working on data loading. So there are three different notebooks. Okay, then, so we one first notebooks, the data ingestion notebook has to run first, and later this one data transformation notebook has to run next, and last what this notebook data loading notebook has to run. So they have to run sequentially, right? So one after the other we have to run. So if you are manually running, so how yeah. Yeah. So if you are manually running, it is not possible. Okay. Because you don't know where the notebook is. So how the notebook is. So what we can do, we can create them as three tasks, and they depend on each other. So once data extraction is complete, then we can run data transformation. Once data transformation is complete, then we can run data loading. So we can do that one in what scheduling. So we can create multiple tasks. So first task will be for extraction, second task will be for data transformation, third one this one. And when you want to trigger it, when you want to schedule it, we can add the schedule, and we can add job notifications also. If the job is failed, then we can add email, we can give email, and the email will say so that job is succeeded, otherwise job is failed. So we can get notification alerts also. You can say, Gopi, so we are scheduling it, but if you don't get notifications, we don't know how it is running, right? So we can add the notification also, that also we can see. Okay, so to manage ETL pipelines, data refresh, report dash, this report generation, for everything what we can do, we can automate this. Okay. Mm, let's discuss all this. Okay, so let me create one job here first. Job. Yeah. So here you can see, just click on this create job, and here we can give the name of this job. So maybe job one, I am giving a job one. Okay. Otherwise, data extraction, if you want to give, you can give data extraction. Okay. So inside this one, we need to provide everything. So here you need to provide the task name. So you can data extraction. The name is data extraction, and the type of this one is notebook, and the source will be workspace only, because then our notebooks are inside the our workspace. Workspace is nothing but this one, this workspace only. We have created our notebook inside workspace, and the path, notebook path, I want to select. From here we can select users. Okay, DB utils. Okay, we have created only two notebooks. Okay, so this one DB utils I want to run. Okay, and then so here path we need to give. So the path we have selected, and the cluster we have to give. So here we can, you can use either job cluster or interacting cluster. So here let me use the interactive cluster. So where, when we find this interactive cluster, okay, 1 minute. Yeah, so Archana K cluster is there now. That is the all-purpose cluster or interactive cluster, we can say. Okay, let me check whether it is running or not. Oh, it is terminated. Hmm. Edit it. It is terminating after. Okay, 20 minutes, 21 minutes. Let's save this. Let me start this cluster. Okay, so meanwhile, what we need to select, the first one, task name, and the next type, this is notebook activity, and the workspace, and here the cluster. So I am using interactive cluster. Interactive cluster is nothing but all-purpose cluster. Okay, so next, here you can see. So any dependent libraries I need to add. As of now, no need. And parameters, I don't want to use any parameters. Notification, yes. So I want to add notification. Okay, so here to email address, I want to add. Copy file. Okay, so on failure and success also, I want to get notification on failure and success also. Okay, save it. And next, you can see retry. Retry means in ADF we have seen, right? So if it fails for one time, so you want to retry it or not? And here you can see schedule. So we can add the schedule also. Continue, save and continue. Here you can add the time. So continuous, no, yeah, active. Here scheduled I want to add. Here you can see advanced. Every a minute. Okay, every 1 minute. No, every 3 minutes. I want to 2 minutes past the hour. Okay, so every 3 minutes I want to run it. Okay, every 3 minutes, not okay, every 2 minutes I want to run. Save it. Yes, the cluster is active and the job is created. Let me run this job. And you can view the run from here.
Gopi, just one question.
Yes.
Uh, where is scheduler?
Schedule.
Yeah.
Here you have seen, right? While creating this, here schedule is there now.
Okay. Okay. Yeah. Okay. Understood.
Schedule edit trigger. You can, okay. What happened? You can see this also. I think dpl start fs dot mount. Okay. Mm-hmm. Okay. Okay. So what we can do? Let me create one notebook. Create notebook. Notebook one. Print the job is running. Okay. Go to workflows and here go to tasks. From here I can select this notebook one. Confirm. Save task. And you can run the job. From here you can see the logs and everything. So now we have started one more job. Yeah, so see the job is running. I want to print this job is running and it has executed. Here you can see here data extraction notebook. Here you can see it is passed. It is succeeded. Okay, so every 2 minutes it is going to run. So it ran for the first time and it is success. And meanwhile, let me show the notifications. You can ask me, Gopi, so will we have enabled that notification, so are you getting the notifications or not? Here you can see, so the first one is error because something is some error is there in that notebook. And now so it has run for one time na success. So that success alert also came here to our email. So this way we can add the schedule, we can add the notification. Okay. Okay, like this you can do. And you can ask me, Gopi, how to add one more task here. You can add one more task here. And the type of this one is notebook only. And here you can give that is data extraction, right? This can be data transformation. And you can select any notebook. Okay. Workplace and mm, let me create one notebook. Notebook 2. Print the second task is running. Okay, yeah, let me add notebook 2 also. And the cluster, same cluster. And here you can see, so this is data extraction and this one is data transformation. Here you can see it depends on data extraction, right? So once the data extraction notebook complete, the run of task one complete, then only it has to start, right? So it depends on this one. And here you can see run if dependent is means. So if it is failed or at least one failed, all done, all succeeded, I will select all succeeded only. If it is succeeded, then only I need to run this one. If it does not succeed, then no need to run off this data transformation, right? So you can click on that all succeeded. And one case can be there. So this task is performing. Okay. So two tasks are there. So if it is succeed, no need to run this one. If it is failed, then only we need to run this one. That time you can select this one, what all failed. Okay. So if it is failed, then only it has to run. You can select like this. Otherwise, at least one failed. Here you can have parallel notebooks and at least one failed, then only it has to run. So you can select whatever the requirement as per your requirement. You can select this one. Okay. So let me add this task also.
Gopi, I have one question. For each task, we'll have to create a separate notebook. Like for the task one, there will be notebook one. The task two will be a notebook two.
Yes, if you have, yeah, for you want to, what the purpose of this one is, like a pipeline, ADF pipeline we are creating here, jobs. So if your task is completing in only one notebook, that you can add only that notebook. If your task is comprised of two or three notebooks, then you can add two or three. So it is up to you. So if you are writing everything in one notebook, then no need of creating second task.
Okay, but one task, one notebook. I mean, notebook cannot be shared
Yeah, yeah,
across
yeah, yeah. One
tasks.
task allows
Okay.
only one notebook. Here giving multiple paths is not possible.
And also, like one notebook cannot be shared across two tasks.
It can be.
So, I mean, data extraction can have notebook one and data transfer also have notebook two. So, how will the Databricks differentiate which part will go for which will be used for data action, which part will be for data transfer?
No, no. Here data extraction and we are selecting right notebook one. So notebook one for data extraction and notebook two for data transformation. We are manually giving this right.
No, what I'm asking is like the notebook one cannot be used in data transfer also, right? That's what I'm asking.
No, you can use
And-
if you want to select notebook one here. You can select.
okay, then how?
Not,
I mean, how will that? I mean, how will I separate the logic between the two if I'm using the same notebook?
no, 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 Sidhu. Here you will write na. So here you are aware of the developer is aware of which notebook is performing which activity. So this one will be for data extraction, and this one will be for data transformation. You know right? If you know
No, no,
already,
yeah, that was my question. That means that one notebook cannot be shared across two tasks.
if it is okay, if the requirement is there, you can add. I mean, some cases in real time, some cases, what happens, right? So this one, how can we say? Okay, mm, okay, yeah, how to say? It? Okay, this data, this is not data extraction notebook. This can be some common functions notebook. Okay, so this common functions you are adding here, first task, and next data transformation, and you want to add this common functions here, then you can add it.
Okay.
The develop, yeah. So how you create ADF pipelines? How you so you will add activities, right? You know, so the developer
Yes.
knows what activities have to add it at what place. You know, first a copy activity, then some other activity. So here also same. Here data extraction this is data extraction notebook. So first data extraction task here, data transformation, then data transformation here. Okay, and if you want to perform, so after this if you want to perform like what, so this can be copy activity, this can be some for each activity. Here if you want to use same copy activity, you can use this activity here, this task here.
Yeah, that's what I mean. That is fine, but data transfer cannot use the same notebook as used by data extraction, right? That was my question.
Yeah, how can you use, so you will write logic here, right? So
That yeah,
inside
yeah.
data
Okay.
attraction, the logic is for data
Okay. Okay.
ingestion.
Got it. Got it.
Inside data transformation, the logic will be for transforming the node data.
Got it.
Yeah. Yes. Here you can see, so we can add how many this one, how many tasks are required for that job. You can add those many. Why it is failing? Mhm. Oh, okay. Sorry, sorry. We have changed the names, right? That's why it is failing. It is failing because we have changed the names. So it is looking for the notebook one, but we changed the names, right? That's why it is failing. So so you are aware of this one. So how to add task, and how to enable trigger, how to enable notification. So everything you understood. Okay. So this way you can add, if there is requirement, you can add. If your task, if your job is completing in only one notebook, you can add only one task. And if your task comprises of 2 or 3 notebooks, you can add those. And if it depends on first notebook, you can add dependencies here. Okay, so otherwise you can delete also. If this one and this one both are not dependent on each other, then what you can do here, you can delete this one. It depends on, you can delete this one, and now they will become parallel, because both are independent, right? So now you can see both are parallel. So both will start at same time. Both starts execution at same time. If second notebook depends on first notebook, you can add here in dependencies, you can add notebook one. Okay, I mean data extraction you can add. So like this, you can play around it, create some two or three notebooks, and try to create this what task and jobs, try to create it. And then you can enable the this one, what we call this one, email notification you can enable. Okay, I am getting alerts, I guess. Yeah, I am getting. So here you can see error, success. So all alerts you can get. So you will run that notebook, the task. If it is success, no need to worry. If it get failed, then you can go to that run, and you can see the logs. So from here you can see the logs. So it got failed, right? So why it got failed, you can see the logs. So here you can see run fail with the error message, unable to access the notebook. This one, notebook one, because we have changed the name notebook one to data extraction, right? That's why it got failed. It is looking for notebook one, but really notebook one was not there. We changed the name. That's why it got failed. Okay, like this you can add, you can create jobs, same as what the ADF pipelines. Okay, so let me delete this job. Otherwise, what happens? So, any doubts on this one, because it is very important concept. So, creating, scheduling the jobs is very important concept. If you have any questions, you can ask me. Okay, so we can use the same notebook in different tasks. So, if it is really required, okay, and the notebooks and everything, the developer knows what logic is inside that notebook. The developer knows. Let me delete this job. You can delete the job like this. Yeah. Okay. Catalog, so catalog is for it is nothing but, catalog is nothing but, so any tables or any files, if you want to store on Databricks memory, inside the Databricks memory, you can create them as delta tables. So delta tables will be stored here. And if you want to store if you want to store some files here, so then you can enable the DBFS. So how to enable this DBFS? Here I am not saying DBFS. Here I am not seeing any DBFS because it is not enabled. And to enable this one, you can go to this settings and advanced. And if you want to enable the DBFS, right here, you can click on this one. So if you click on this one, the DBFS is enabled here. You can see DBFS here. Where? Let me refresh this. Yeah, so see here, browse DBFS. So if you want to store some files, so any important files, if you want to store on Databricks memory, you can store here. And this compute, so this compute is nothing but creation of clusters. So all-purpose compute means interactive cluster. Okay, so they are active 24/7. Okay, so here you can ask me, Gopi, if it is active 24/7, and if you are not running any jobs or any workloads are not running, then it is going to incur cost, right? That's why we keep terminate after 20 minutes of inactivity. So if nothing is running on that cluster for 20 minutes, then it is going to be what shut down, so that we will it will not incur Databricks costs. Okay, so this one. And if the workloads in our real projects, what happens every time? So there will be 200 to 300 pipelines, and some hundred of jobs are working running on this one, right? So 24 by 7 the pipelines are running on this cluster. Okay, so then that time we can use this all purpose cluster. Okay, if you want to keep, if you want to keep separate compute or separate cluster for each pipeline, that one also we can do. What we can do, you can go to job compute. And okay, so here let me show you how to create job compute. So the difference between this all purpose and job compute is, this all purpose cluster will be active 24 by 7, and you will give, so how if it is inactive for this much time, terminate this one. Otherwise, if it is active, then it is going to run 24 by 7. You can run any number of pipelines on the same cluster. If 100 pipelines are there for you, so you can run 100 pipelines on the same cluster. But for job compute, so only one pipeline will run for one cluster. So these are job compute clusters are temporary cluster. Okay, so see here, we can create one job. Job I can create here, job 1. Here you can see, either you can select this existing cluster, otherwise you can create one job cluster. Okay, so this job cluster single node. Okay, this version not a problem. The account may not have enough CPU cores to satisfy this request. Okay, how much? 14 GB also not available. Okay, so let me show you. So like this, you can select whatever the if it is big workload, you can select 32 GB or 64. If it is small data set, you can select 16 GB. Okay, uh, and you can confirm it. So what happens, right? Here we have created job cluster. Okay, where? Yeah, let me confirm this. Here we have created job 1 cluster, right? So it will be, this job 1 cluster will be for this job task only. So if you have one, if you want to create one more task, if you want to create one more what, not task, if you want to create one more job, so then that time, so this job 1 cluster will not be visible there. So you have to create one more cluster there. So for this job cluster is specific to this job only. Okay, so whenever this job is enabled, whenever you trigger this job, that time it will be spin up. Whenever this job is completed, then it is going to be terminated. Okay, like that we can save cost. Okay, so this job clusters are specific to this that particular pipeline or job. So it will be activated whenever the job is active. The schedule time is, I mean, whenever the job is scheduled, that time only it will be activated. Whenever the pipeline or job is completed, then that time it is going to terminate. So if it is running, the job takes only 20 minutes. So this cluster is active for only 20 minutes. So Databricks cost will be there for only that 20 minutes. But the problem with this compute is, this all purpose compute is what, if it is it is normally in our real time, so we'll keep 1 hour or 2 hours. So for if nothing is running on that for 2 hours also, it will be active. For those 2 hours we need to pay. So if all pipelines are running, no problem. If nothing is running, still it will be not terminated. It looks for 22 hours. So here I have given only 15 minutes. In general, in real time, they will give 120 minutes. So if you for one, it will keep alive for 120 minutes. Even though nothing is running on this all-purpose cluster, it will be active for those 2 hours, and they will incur costs. So that is the problem with this all-purpose cluster. So you understood, right? What is the difference? In interviews, they will ask you. So if we have scheduled pipelines, so which cluster you are going to use? So for scheduled jobs or scheduled pipelines, you can use what? Job cluster. Okay, because that job cluster will run at that particular time only, and it will be terminated. If we have real-time processing, then we can use this all-purpose cluster. The data is real-time, so you have to process 24 by 7 the data. Then you can use this all-purpose cluster. Okay, understood? The difference between all-purpose compute and job compute. Have you understood, guys?
Uh, Gopi sir,
Yes, yes.
suppose cluster is deactivate, And same cluster again after 2 to 3 hours can be activated or not?
If any pipelines, okay. So a good question. What at 1 p.m. Okay, at 1 p.m. no pipeline is running from 1 p.m. to 3 p.m. So 2 hours of inactivity, this will be terminated. Okay. So at 3 p.m. it is terminated. At 4 p.m. one more pipeline triggered. I mean at 4 p.m. one job or pipeline got triggered. Then what it starts, it will activate it. It automatically at 4 p.m. So the pipeline will ask cluster, I want to use this cluster. Then it is going to activate at that time.
Okay. This is happen in job compute or all purpose?
Both.
Both. Okay. Only
Yeah.
we need to schedule the.
If you schedule it, it is automatically going to spin that cluster.
Okay. Okay, sir. Thank you.
Yeah. Any other doubts, guys? Yes. The next thing is yesterday we were talking about asset transactions, right? Am I getting the notifications? I think now the notifications are stopped. Yeah. Hey, 1 minute, guys. Yeah. So we were discussing about jobs. It is completed, email. Hmm. So yesterday we were discussing about data lake and delta lake. So while discussing delta lake, I told you like the delta lake supports this one asset transactions. So what is meant by asset transaction actually? Okay. Hmm. So it is one of the most important concept in data engineering, guys. So in interviews, they may ask you, so what are the asset transaction? What is the importance of this delta table? So what is asset transaction? Will it support or not? Delta lake, they can ask you. Okay. So whenever delta tables is there, so you can whenever someone asks you, so what is the importance of this delta lake? You can say, so delta lake allows only structured data. Okay, so schema enforcement or schema validation is there, and one more thing. So it supports whatever the SQL tables does. Same kind of stuff we can do here. And one more thing. So this one, it supports ACID transactions. ACID transaction, ACID. So ACID transactions means atomicity, consistency, isolation, and durability. So I told you what is this atomicity. So let's discuss one by one. Atomicity. So atomicity means, guys, all or nothing. So either all the either I mean, so everything is done or nothing is done. Either 100% success, otherwise 0% success. Okay. So that is the atomicity. Means either all operations in a transaction succeed or the whole transaction fails. So it means how can we say, either all operations in a transaction succeed or the whole transaction fails. So what happens? So we have, okay, let's think that we have 2 or 3 operations for a transaction. Some operations are there for a transaction. So all operations are successful, then it is okay. If a second or third operation is failed, so we failed at second or third operation. First operation is success, second operation is success, third operation get failed. Then, so in this case, what happens? So everything will be rolled back. Okay. So if one step fails, so everything is rolled back. That is the atomicity. So either everything is happened, otherwise nothing has to happen. So okay. So you what is the real time case is? So if you are inserting three employees records, if the second one fails due to schema mismatch, okay. Uh, so what has to happen? So first person record has first person record is good, but so if the second one fails due to schema mismatch, so none of the records are inserted. What happens? So three records will not going to be inserted. They are going to roll back. So already first one is inserted, but what it is going to do? So it is going to be rolled back. So either three records will be inserted, otherwise no records will be inserted. Otherwise, what we can say? I told na that phone pay example. So if you want to send money to one person, so if you whenever you click, whenever you send that 1,000 rupees, it has to be credited to that account. Otherwise, it should not be in a pending mode. Many times we will see that pending mode, right? So it should not happen in Delta tables. So in Delta Lake, so it will not happen. So either if you send the money, either he is going to get the money, otherwise, so you will get the refund immediately. So if it is cut, if it is debited from your account base, it has to be credited to him. If it is debited and it is not credited to his account base, so it will be rolled back. It will be refunded back to you. That is atomicity. You understood, right? Then next, consistency. From here on, guys, so we are going to have 3 or 4 Databricks classes. But so it will be all interview based concepts only. Okay. So because we have covered all the transformations parts and delta table creation and ADLS mounting. So maybe on Monday, I will discuss how to connect to the SQL database. We can discuss. After that, everything will be this one only, interview based only. These are also interview based, and I will explain. Today, we are going to see what is the difference between CSV and parquet. So when we use CSV, what are the disadvantages of CSV? What are the advantages of parquet? We will discuss. That is also with respect to interview only. Consistency means valid state before and after. Before and after, it should be in valid state. Valid state before and after. So it means, so a transaction must what we can say, a transaction must transition data from one valid state to another valid state. So before and after, so before the transform transaction, so before whatever it is in the state, so it should be in valid state, and after also it should be in valid state. Okay. So it enforces data constraints, schema checks, are and data integrity. I mean, so so we while I am discussing SQL, we have seen what. So this column should be, so this column what employee ID column should be integer. So before that one also, before that transaction, if you are going to insert three records into that column, so before it is employee ID is what, integer. After inserting those three also, the three records must be integer only. Then only it will allow. So it is the schema what enforces schema validation, data constraints, and one more thing. So the column, age column allows has the constraint. What constraint? If, this one, age should be greater than or equal to 18. So before the transaction, so age should be below above 18. And after inserting those three records also, age column must allow the three records if the age is greater than or equal to 18 only. It should not allow the age less than 18. So that is also what comes under consistency. And means, so we will have some set of rules, right? So we will give some set of rules on the schema or constraints, anything. So the records, the incoming records, so every day has to obey those rules. So before and after, it should be in the valid state. Okay. Yeah. So like employee ID should be not null. So the constraint is employee ID should not be null. So before and after, before performing the transaction and after performing the transaction, it should be same. So it should not allow the new, you are inserting those three records. So in those three records, employee ID should not be null. That is the consistency. And third one is isolation. Isolation means safe, we can say parallelism. I mean, you are performing multiple transactions. At a time, you are performing multiple transactions. I mean, so you are sending money to two or three persons at the same time. From laptop, from phone, from other device, you are going to start your sending money. So what in our organizations also, what they will do in one click, they are going to send the money to everyone, right? So if 1 lakh employees are there, they won't send individually. What they are going to do, so they are going to schedule the transaction, this one. So at a time, the money is going to credit in all accounts. Okay, so but one transaction is independent of each other. I mean, so if one transaction is failed, so it should not fail all other transactions, right? So if I did not get credited, so all other 99,999 people should not get, not, it is not like that, right? So those transactions are independent, and they follow parallelism. Okay, so multiple transaction can occur at the same time, but they don't affect each other. That's it. So if it is failing because I have removed my account, or branch has seized my account, or something has happened, it is not allowing incoming or outgoing. So what happens that time? So my transaction will be failed, but other transaction, other employees will get money, right? So that is the isolation. So my transaction will not affect others' transaction. That is the safer parallelism. So multiple transaction can occur at the same time, but they don't affect each other. Okay. So it guarantees that the result will be same as if the transactions ran one after another. Okay. Yeah. And the last one, durability. Acid. D stands for durability. Okay. So durability means once saved, always saved. Okay. It means after a transaction is committed, the data permanently written to storage. Okay. Okay. How can we say? So if there is a system crash, or the power failure, or internet connection issue, so the changes will not be lost. Okay. So you made some changes. If there is a natural calamity, or some human errors, or something has happened, so even though anything happens, it should be what, the changes will not be affected. Okay. Mm, yeah. So how can we say, if a transaction commits and data caches right after, the data is still there. So when you come back, okay, uh, if any thing is there, it is not going to affect the transactions. Once you send that money, what we can say, once you save those changes, so they will be saved forever. Okay, so the power failure or system crash or anything will not going to affect those changes. So that is the durability. Hmm. Mhm. I think this is sufficient. Okay, let me show you guys. Yeah, I forgot to show you this. Okay, so you can ask me, Gopi, how to run one notebook from other notebook. Okay, so here, maybe this one we are using, this is utilities notebook. So inside this utility notebook, you are having all the common functions. Hmm, this is the problem, guys. If I keep this one, yeah, it is starting, no worries. Yeah. So here notebook one contains what, all the utilities are all the common functions. So everything it is comprised, consist of. So every developer is going to this use this common notebook. Okay, common. So this contains useful information, or something related to URLs, database information, or passwords, or keywords, or something. So it is going to have everything, the common functions which we can be used by everyone in the organization. It contains them. So then what every developer will do? So maybe I am working on this notebook too. What I can do? So I want to run this notebook, right? Because so I don't want to write the functions here. I don't want to include here because they are already inside one notebook. I don't want to write them here. Okay. So how can we add? How can I import this these commands or these variables or this notebook here? Just you need to add percentile run. This is magic command. Percentile run, and you just give the path of this one. Let it start. Yeah, this is available. Okay, so see, I ran this one, right? Percentile run, the path of the common node. See, the job is running. Let me write something else. Okay, let me give A equal to 10, B equal to 5, C equal to Gopi, and D equal to some www dot gopikrishna.com. Okay, A, B, C, D. Okay, so let me go here. Let me run this one. Okay, so let me print A. See, we haven't defined A here, but so A value it has printed. It hasn't thrown error because A is inside this common function. We have imported that common function here, so we can use all this. So inside this a common function, we can have the all database names, all environment names, all URLs, all functions, everything we can have in this one. So no need to define all of this here. No need to define the database name here. Directly, you can use that database. Let me use that one. Maybe something like this one, right? The database is some Marcel client. Okay, the database name is some Marcel client. So I can directly use this Marcel client. So here, database D, print D. Yeah. Okay. Okay. So why is printed? We have to run this one first. Yeah, printed. So I can use whenever I require this database now, just I can use D instead of writing this Marcel client here and remembering all these all the time. So what you can do, you can use this one. So whatever the variables you have created there, you can use them. So this way we can run the one notebook from another notebook. Understood? Mm, what we can discuss? We have time. Okay. Yeah. Let me. Yes. CSV. So we will discuss about CSV5. Okay. So CSV stands for comma separated value. Let me show you what is CSV. I think we have this is CSV file. Yeah, you want to say something? Someone? Yeah, here you can see this is CSV file. The first one is header. Okay, so it contains column names, and the second, these are the values. So the first row indicates the first row. Okay, this one indicates the first row inside the data frame. Second one indicates the second row inside data frame. Okay, and everything. So employee ID, all are integers. Name, all are string values, country, all are string values, and department, all are integer. So how it is arranged means, so they are separated, the fields are separated by comma, and the values also separated by comma only. Okay, so what happens if you by, because this is text file, right? So human can, we can, developer or user, anyone can change the data. So instead of this one, you mistakenly write it written here like this, USA. Okay, what happened now? Country is one, department is USA. Mistakenly we have written. What happens? So that wrong data will, what wrong data will process, because we are not enforcing any schema here, right? So employee ID, it can be anything because it is a text format. So it allows anything. So name also allows anything. Country also allows anything. Department also allows anything. But inside a table, so we can't change like that, because so SQL table allows what? ACID transaction. So schema enforcement is there. So department column is integer. It allows only integer. So you cannot edit the the tables or delta tables or SQL database SQL tables if you, like this, because it is a text file. So that I am editing like anything. We can edit like anything. But in real this one, what SQL or parquet file, it is not possible. Okay, so because there is schema. So employee ID allows only integer, name. Here we are not enforcing any schema, right? So here, can you see any schema, or have we defined anything? No, right? So that is the problem with CSV. So it is a plain text, yeah, plain text formatted file. Okay. So data is stored in a tabular form where each line separates a row and columns are separated by commas. Okay, here you can see each line represents one row and columns are separated by commas. Here you can see comma. So columns are separated by commas. This is the first column. So 1, 2, 3, 4. This one is the first column. And John, Alice, Robert, this one is second. So how they are separated by commas. Okay. And each line represents one row. So how rows and columns are differentiated? Each line represents one row and columns are separated by commas, are the delimiters, we can say. And they does not support what? They does not support data types. So everything is treated as what? String, unless until explicitly we cast it. So inside Databricks we can cast, right? If you cast, then only what? So the schema is going to change. Otherwise, one thing you have to use infer schema. Okay, so you have to use infer schema. Otherwise, you have to use explicitly define the schema. We have seen using struct field and struct type, we can explicitly cache the data. So otherwise, what it does, if you don't use that parameter infer schema equal to true, it is going to treat everything as string. That is the problem with CSV. So does not support data types. So everything is treated as what? A string unless explicitly cast. And no compression by default. Compression means, yeah, let me show you. Let me write here. So first thing, it is a plain text file. Anyone can edit. And one, so data is stored in a tabular form, yeah, where each line represents a row and columns are separated by comma. And next one, so it does not support what? Data types. Does not support data types. Everything is a string only. If you explicitly, I mean, if you have to use infer schema, or you have to use struct type or struct field, then only the schema is enforced. And no compression by default. Okay, let me open this one, parquet file. Where we have this parquet file? Somewhere here. Yeah, this one is parquet file. Let me open this. Here, can you see? Can you read anything? So this parquet is a compressed file. So it will be in, maybe they are using hexadecimal or some coding encoding they are using. So that's why it is. So how to say, the file size, if the original file size is 100 GB, if you use parquet file, it will be 80 GB or 70 GB only, because it is encoded. So we are not using the real data, it is encoded data. But inside this one, inside this inside CSV, we are not using any coding, so it is not compressed file. So if it is originally 100 GB, it is going to be 100 GB only. But inside parquet, so the compression is possible. Like the good example is, so if you have 2 GB file, 2 GB, we have seen. So earlier we are using those file movies we are downloading from internet and we are watching, right? So 2 GB file is there, 2 GB video file is there that contains one movie. Okay, if you convert that video file, MP4 file or some file to zip, if you zip it, the size is going to reduce or not? Guys, you know, so this real example we know. So whenever you convert any file to zip, compress it to zip folder, the size is going to reduce, right? Yes. Yes. So same. So it is a compressed file. The zip file is compressed file. Here also we are not using the actual file. So you want to watch movie? Can you watch the movie from zip file? Not possible. We have to extract the file. First we need to extract. Once we transform the data, na, so first the GB, the movie is 2 GB, and when you compress it to zip file, it is going to be 1600 or 1600 MB or 1500 MB. So if you can transform that file to someone, and they cannot watch the zip file directly, what they have to do, they have to extract it. So when they extract it, it will become 2 GB file only. So we are not sending the real data, we are sending the compressed data. So that's why it is the file size reduced. But if they want the real data, what they have to do, they have to unzip it, they have to extract it. Same way. So we are sending in CSV files, we are sending the real data. That's why the compression is not possible. So in parquet file, we are sending the encoded data or compressed data. So it is not able to read like zip file. Zip file we cannot read, right? Same here, we cannot read the parquet file. We need separate tools to read or edit this parquet file. Okay. So here Databricks is one tool where we can read the this one, what parquet file. So that's why compression is allowed in parquet and it is not allowed in CSV, so that we cannot reduce the size. And no schema in this one, no schema. So structure has to be inferred or manually defined. I told na. So you have to use either infer schema, or you have to explicitly define that struct type and struct field you have to use. Then you can ask me, Gopi, so you are telling all the disadvantages, then why we are using this one? Why CSV? Because it is easy to generate. Okay. So it is easy to generate and consume and process also across various tools. So inside Excel file or Python or SQL or anywhere. So it is very easy to generate. If you want to do some, you are doing some research and one of the feature. So what you can do, so to create dummy data, it is very easy to create dummy data using CSV. It is very difficult to create dummy data using Parquet. So what you will do, you will use this CSV. It is very easy to generate and it is very easy to process also and consume also. That's why we are using this CSV. Whenever the data size is very small, then you can use this CSV. Okay. And what? Yes. Any doubts, guys? Someone is speaking. Yeah. Yeah. So it is good for data exchange between system, because so it doesn't have anything. No need to check schema. No need to look for compression, whether it is encoded or not. No need to see, and data types is not there. Okay. So it is very plain text. So it is good for data exchange between system also. And it is ideal for small data sets or initial loading. So for initial data collection, what we can say for initial data collection, it is very easy. Okay. So it is very, if the size of the this one, if the size of the data set is very small, we can go for CSV because encoding is not possible in this. But if it is very small and it is very easy to exchange and generate and consume also, so we can go for CSV. And uh, what are the advantages of this? So the advantages are, so human readable, so human can read it, and editable, human can edit it, and supported by all uh, platforms, what we can say, almost all platforms. Mm, and programming languages. So all programming languages support this CSV. All platforms, every platform supports this CSV, and easy to debug or manually inspect data. So whenever the data is wrongly processed, you can go to this one, you can go to this file and you can see manually we can inspect the data. Oh, so yeah, first column is good, second column is good, oh, third column this is wrong. So we can easily debug and what inspect the data in CSV. Okay, so these are the advantages and disadvantages. I think you know, so these are the disadvantages. So the compression is not possible, so larger size. Yeah, let me, it is, the disadvantages are, so larger size files due to no compression. So there is no compression, so we cannot process the larger size file. And slower read or writes for large data sets because the size is very large now. So slower, the read and write time will be very slow. And no support for complex data types. I mean, so if you have the data, so like skills, you have the skills field. Okay. So if you have the skills field here, after department, you have skills fields. In the skills, we have three or four. So Gopi can have John, this John can have three skills. Elias can have four skills. So how can you add those four skills in one column? It is not possible, right? So the column has to be, it has to be the column. So if you want to add three or four, it has to be array type or list type, right? So list type, it won't allow. So it will allow only one item, right? So it is not possible. Understood? So no support for complex data types and schema inference needed every time. Yeah. So we need to use that infer schema every time. Schema inference needed. And one more thing. Hmm. And it is prone to what, data quality issues, because mistakenly while generating or something, so mistakenly you have added one extra comma or you have removed one extra comma. What happens? So if you remove this one, how it is going to treat this country is USA1, department value is null. Okay, so like that. So it is prone to data quality issues because extra missing commas or escape characters or something. So if it's there, then the data is going to be fault data. So these are the this is about CSV, guys. So CSV, I think everyone understood this. Why CSV? What are the advantages? These are the advantages, and these are the disadvantages. Any doubts? If any doubts, we can discuss. Because in interviews they will ask you. So what is the so because everyone uses parquet file, right? So I mean, not everyone uses. Everyone suggests to use parquet file. So they will ask you. So which file for you in your project? So which format of data you are using mostly? They will ask you. Why can't you go for CSV? Why you are using parquet, they can ask you. And what is the size of your input file, they can ask you. So how much data you are processing, they can ask you. So you should be in a good position to explain all this. Okay. Yeah. Hmm. Parquet file format. So whatever the disadvantages of CSV, these are the advantages here. The characteristics are, and it supports columnar storage format. So here in CSV, how, so the if you want to read the data, so one first you need to read one date, one row. If and second row next, third row next. Okay. If you want to write the data, first row you have to write, second row you have to write, third row you have to write. But row wise, it is row wise reading or row wise writing. But in Parquet, so it is like column wise. So it will write all the first column first, second column first, third column next, fourth column next. If you want to write also, if you want to read, first column read it first. This one it read second, third column read third. So like this. If you want to write also, first column is written first, second column is written next, third column. So like this, it is a columnar storage format. Either reading or writing, it is columnar storage. So the good thing is whenever you are coding on the columns, so inside CSV, if you want to only country, you want to know only country, or you want to extract only name field. So it is very difficult. So because in CSV file, what happens? First it will read the, what it does, it will read the first row. And first row, it will read everything of first row and it will select name. And second row it will read and it will select this one, and it will read third row and it will select this one, because it is row wise read and write now. So it won't read directly this name field in CSV. But in if you want to select only name column in Parquet, it is reading and writing in what format? Columnar, right? So what it is going to do, directly it can read everything of name column. So if you want to, if you are performing some SQL queries on columns, if you want to select only selected columns, then it is very good. The query performance very good in Parquet. You understood, right? So everyone, because it is very, very important, guys. The what is the advantage of Parquet format? They will ask you. First and foremost, first you need to tell columnar storage format. That is the so the interviewer will not expect anything from that. So he expects only the columnar storage format. In CSV, so it reads or writes are what row wise, but in Parquet it is columnar wise. So first column will be if you want to read all the columns, first this one will be read second this one. If you want to read only selected columns, you can read directly name column. But in CSV, you need to read the first row, and from the first row you need to select this one, and second will be read and it will select this one. So the reads and writes are very what very it takes very huge time in what CSV, but in Parquet file, so it is very fast due to columnar storage. Understood? If you are not able to understand, then ask me, guys, because it is very important one. So if you understood, well and good. If you don't understood, ask me. So CSV and other row wise reading and writing, and Parquet column wise reading and writing. Yeah, so columnar storage format and supports schema with data types. So in schema, so we have seen delta format is nothing but a Parquet format. So it supports whenever you want to, whenever you are creating this columns now, that time you need to give data types also. So it supports schema. Okay, I mean this supports schema with data types. So mm, it supports compression also. Compression means we have seen, right? So human cannot read it. So the 100 GB file we can transfer you, we can encode it. And mean if you use Parquet file, it will be the data is 100 GB, but if you use Parquet file, it will be 80 GB only. So we can process it very easily, and it is designed for heavy or large. We can say heavy. Uh, yeah, read heavy operations because it supports compression. So it is designed for read heavy operations. And why we use this parquet in our data engineering? Because it is optimized for analytics queries and large scale processing. Yeah, so it supports compression. So for data analytics, and it has columnar storage, right? So whenever you are performing this queries, so queries will be a column wise, right? So you will perform select you are going to select columns. So it is stored in columnar storage. So whenever you are performing this data analytics or for large scale processing, you can use this parquet, and it works efficiently with data lake storages like ADLS, S3, because they that yeah. So what you can say, mm, like CSV, they also support in ADLS or S3 bucket. We can store any files. So likewise, we can store Parquet file also. Mm, and the advantages are highly compressed. Okay, so resulting in smaller storage. Yeah. So compressed highly means storage space will be, it requires very less storage space. So yes, and then faster query performance due to columnar storage, columnar format. So only needed columns will be only needed columns are selected. So so it is suitable for this faster query performance. Yes, it supports. So we can give data type, right? So it supports complex and nested data structures. Like it supports nested JSON, and it supports arrays, and it supports maps. Every many complex data types it supports. Mm, and some disadvantages are, so not human readable or editable. Human cannot read and edit it. Slightly more complex, right? Because CSV, it is only plain text, but it is a coded, I mean, complexed one. Okay, so that, and we have to manage that data structure, and we have to manage the schema validation. Okay, schema also we have to manage. So it is more complex to manage for beginners also. And this we have this one, but compared to CSV, it is more complex due to this all. So schema and what data structures we have to manage. Yeah. Mm, okay. So I think this is sufficient. Okay. So when we use CSV means when the data, so the summary is whenever you want to, whenever you have small or medium size files, you can go for CSV. And so yeah, you are, so sometimes what happens, guys, client will say, so we have some non IT people, non-technical people we have. So we are sending these files to non-technical people. So we want it in CSV only. They will ask sometimes. That time we have to process CSV files only. Okay. So you need to share the data with non-technical users. Then we need to use CSV. And for initial ingestion and prototyping, whenever you are doing POC or some research, you can use this CSV. And simpler workflows without complex data types. So the data so is very simple, and it doesn't have some complex data types like array or a nested JSON, or I mean nested something like that. You can go for this CSV, and we have to use this parquet whenever you are working with large data sets, and you want, if you want to perform some analytical queries, you want to perform that time, you can go for Parquet because it stores the data in column wise. And so if you need faster performance, because reads and writes are very fast in Parquet. So if you need the performance speed, if you want speed performance should be good, then you go for Parquet. And if you are handling larger data, I mean not larger, complex data sets, it has array or some nested data types if it has, so then you should go for parquet. Yeah, I think this is sufficient. So whenever the interviewer asks about this CSV or parquet, so you should be in a good position to explain all this. Yeah, if you have any questions, you can ask me, guys. I think it is Friday.